Welcome to the second part of this very short introduction to Python. This will be about lists and arrays, more complex data types, and also an introduction to the Numpy package to show you how packages are loaded and to motivate the use of packages, which make Python so powerful and the most important tool for deep learning. Let's start with lists and arrays. In the last Colab sheet, you have learned some data types: integers, floating type numbers, strings, and Boolean. And arrays or lists, they're basically the same in Python, array and list. That's why you will use the word interchangeably. If you have done programming before, technically it's a list in Python, but it behaves like an array in other programming languages. So here in that first example, I define an array and I store this array in variable a, and this is an array of strings. And what is an array? An array is basically just something that holds more than one variable. So an array is defined by these brackets here, and its elements are separated by comma, and this is an array of strings. So the first element of the array, which technically is element number 0, is the string blue. The element number 1 is red, the element number 2 is green, and the element number 3 is yellow. And then I can, for example, print all my elements of an array. I can print element number 0 and element number 3. So you might ask, why does counting start with 0 and not with 1? This is the case in many programming languages, that indexing in arrays starts with 0. Just something to remember. The first element is element number 0, then number 1, 2, and 3. So the last element of an array with length 4 is element number 3. And we can execute this short snippet of code that defines array A, and then it prints element number 0, which should be blue, prints element number 3, which is 0, 1, 2, 3, yellow, and it prints length of A, and then calls the function len, which returns the length of A. So the length of A is 4 because A has 4 elements. So that's basically it about arrays. An array holds more than one value. It is one variable, but it has more than one value. And you can get to each element of an array via its indices. And there are a few more things that you could do with arrays, like iterating through it, but we're not at that stage yet. So at the moment, A is a list. A list is the same as an array in Python, basically. It has 4 items, and those 4 items are blue, red, green, and yellow. All of them are strings. In the next example, I will show you that arrays cannot be just one-dimensional, but they can have more than one dimension. And technically, it's not a 2-dimensional array, but a list of lists. So I define the same list or array as just before, that has values blue, red, green, and yellow. I define a similar array, again, for elements: bird, tree, city, and hand. And with the outer brackets, I have here a list of lists. And this will be a 2-dimensional array. So when I then index on variable b, then I can say, give me element number 0 of b. So 0 is the 0th element of these 2 lists. And then I have the second index 2. So within element number 0, I take element number 2, 0, 1, 2, that is green. And then I take element number 1, 3, should be the last one, hand. So let's execute this. And yes, element number 0, 2 is green, and element number 1, 3 is hand. If you look at the tooltip, it will tell you list B, it has 2 items, and each item is again an array. So the take-home message from this snippet of code is we can have more than one dimension in an array, and this will be very useful, especially when we have multi-dimensional data structures. So much about built-in arrays, which are technically lists in Python. Those functions are pretty limited. And to have more functions for things to do with numbers, there is a package in Python called Numpy. And Numpy is just short for numeric Python, but its name is Numpy. If I want to use Numpy, then I need to import that package. So I need to write import Numpy. And if the name Numpy is too long, then I can say import the package Numpy, but from now on, just call it NP. And that's usually done by everybody. That package Numpy is called NP because we use it so often that we abbreviate that even further. So I import package Numpy as NP, and now all of NP's functions are available for me. And the first thing that I could do is create an array with numbers from 100 to 1000, which would be quite tedious if I just write them all as I did before each element itself. I just want a function that says all functions from 100 to 1000. And in this case, not all numbers, but each 7th number. So starting from 100, each 7th number up to 1000, and store that to my variable called a. So what is a now? Will the tooltip give me something? So a is an ND array, and it has shape 129. So it has 129 elements. I could also look into my variable explorer right here. So here I have array A, and it has 129 values, starting from 100, then 107, 114, each 7th element, until 1000, and the last element is 996. So this is a very fast way to create arrays with numbers. And this function that does that for us is arrange. It has 3 parameters. The first element, the upper limit, and the step size. If you want more fancy ways to create arrays, then you could just Google NumPy create arrays, and this will lead you to the documentation at numpy.org. Whenever I don't know something in programming, I Google for it. And quite often it will give me to forums that give good answers. Not always the first result is a good one, but the second or third. Or it will take me to the manuals of the packages. Let's play a bit more with NumPy, what we can do. Here, another function, NumPy zeros. Zeros creates an array that has only zeros in it. And I can define the size of the array. So in this example, I create a 6-dimensional array. The first dimension has a length of 3. Second dimension has a length of 4. The third has a length of 3 again, and so on. So this will be quite a huge array because it will have 3 times 4 times 3 times 2 times 3 times 5 equals 2160 elements. And all of them are 0 at the beginning. This is quite useful in data science. I have 6 dimensions. I want to give it an initial value 0, and then I can populate it with the actual values. And again, in data science, each of the 6 dimensions is quite short, but because of the number of dimensionalities, it has quite many elements. So if I want to do a computation with each single element, this can take quite some time because it's more than 2000 elements. Numpy has more interesting functions. For example, Numpy has a sub-package or module called random, and that again has functions to call functions to create arrays with random numbers. So I create 100 random numbers and store that array in variable called C. And then I do the same with D. It's a slightly different function. It's not rand, but randn. The difference between rand and randn, again, you could just Google it, but I can tell you rand gives a uniform distribution between 0 and 1. Randn gives a normal distribution with a mean 0 and a standard deviation of 1. And then I can add those two arrays because they have the same length. Then adding those 2 arrays will actually work. So let's see what the output is. I have C, D, and E. Those are all arrays, and they have random numbers in it. So C, the first element is 0.61 and so on. The second element is 0.25 and so on. So all the elements are between 0 and 1. And for D, I should also get some negative values and values bigger than 1 because all of them are random number drawn from a normal distribution. And E is just the sum of the two. So 0.6 something plus 0.9 something is 1.5 something. And Numpy is a quite powerful package for everything to do something with math. And that's demonstrated in the last snippet here. So I print some mathematical operations. So I can print out the mean of C, so uniform distribution between 0 and 1 that should be around 0.5, not exactly because I have only a sample size of 100. I can calculate the standard deviation of C, so that is the standard deviation of a uniform distribution between 0 and 1. If I guess correctly from my math lecture, that should be around 0.3, but you could calculate it by yourself or do it empirically by not using 100 elements, but 100 millions or so. Yeah, and then something more interesting. What's the correlation between C and D? Is there a correlation between 2 random vectors, one a uniform distribution and one a normal distribution? What correlation coefficient will you get at a sample size of 100? I leave that up to you. And is there a correlation between C and E? Between C and the sum of C and D. So there should be a correlation between, because that variable C goes into it. We can just study that empirically with our code that we just created. So the mean of C is close to 0.5. The standard deviation is 0.27 something. And then the first correlation between C and D, it actually gives the correlation matrix. So it correlates C with C, which is obviously 1. And then it correlates C with D, which is slightly negative, but very close to 0. And then again, correlates D with C. So those 4 elements, it's a symmetric matrix. And then again, D with D. So 2 random vectors have a correlation of close to 0. And C and E, where C is a part of E, have a slightly positive correlation. So I could run that code again and see what happens again with 200 new samples. So this is now a different, should be a different sample, unless I need to set the seed again. And this is actually true. So when you have random numbers in Python, what I did not set is a random seed. So it always uses the same seed. So it's just pseudo-random. If you want to get new random numbers, then you need to take care of this too. But this is not part of this introduction. It shall just show this is Numpy, a package of Python that can do many things. So if you want to calculate the mean, standard deviation, correlation coefficient, you have functions for that. If you want to create arrays of numbers, there are convenient functions to do that, random numbers, zeros, ones, and so ever. If you have a specific problem, then the way to do it is use Google, go to the documentation of Numpy and all the functions that it offers, but usually I don't read through the documentation. I Google for my specific problem, and that brings me back to the Numpy or other packages manual. So that's basically it. Thank you very much for watching this second part, and we will have 4 more parts in this very brief introduction to Python.